Hello everyone. The topic of my presentation is zero-shot translation among Indian languages. My name is Rodali Hudrom and I'm from Waseda University, Japan. Before I begin the presentation, I would like to give a brief outline of our presentation. So first we will discuss the background in which we will talk about language description, dataset description, and the motivation of our research. Secondly, we'll talk about the proposal. So we'll talk about our method and we'll give an explanation to it. Lastly, we'll talk about the experiment and result, and we will give a conclusion, overall conclusion to our presentation. So we are talking about a language, a very low resource language called Manipuri, which is an Indian language from the Sino-Tibetan language family. There are two writing systems for this language. The first one is called Eastern Nagari script, and the second one is called Meitei Mayic. For our research, we are using Eastern Nagari script. Manipuri shares writing system, which is Eastern Nagari script, with Bengali and Assamese. And talking about the lexical influence, Bengali influences Assamese and Manipuri, and Hindi influences all the other three languages. So these are the languages that we are considering for our experiments. About the language status, this language is labeled as endangered. Yeah. The dataset that we are using is the PM India dataset. Uh, there are 13 language pairs in this dataset, but we are considering only 4 language pairs for our experiment, which are the Assamese English, Bengali English, Hindi English, and Manipuri English. As you can see from the statistics of the dataset used, Hindi English has the most number of sentence pairs, and Bengali English have half of Hindi English sentence pairs, and Manipuri English has the least. The word per sentence, average word per sentence is between 15 to 20, and uh, the word types, we know that it's obvious that the language pair which has the most number of sentence pairs will have the most number of word types. So Hindi English has the most. But we can also see, we observe that in Bengali English, the Bengali part has more than the Hindi, uh, even though uh, even though Hindi English has almost, you know, double of what Bengali English has in terms of number of sentence pairs. Moving on, our main goal for the experiment is to achieve machine translation for a very low resource language called Manipuri, in context of training with other Indian languages between which no parallel data exists. What we propose is to measure the effect of using zero-shot machine translation system, for low resource languages on balanced dataset settings. In order to implement our proposal, we present to you the following methods. So the first method is the single model, in which uh, they train the single language pair, where one for each language pair. The second one is multilingual models. So what happens in multilingual models is these models are trained on data on different types of multilingual data. So there are many ways, like one to many to one, and many to many. Lastly is the zero-shot models. So in the zero-shot models, what we do is we are trying to test zero-shot translation on language pairs for which no parallel data was seen during the training. A brief explanation to what I just said. So single models is something like you have a language, say X, and since our corpus is something like Indian language with English, so in our case it will be some language X with into English. So our single model, what it does is it translates language X into English and English into language X. Multilingual model is, as I mentioned before, there are three types, which are one-to-many. So it means like one source language translated to many, target languages. So in our case, it will be English into language X. Many to one is the other way around. So it is many source languages translated to one target language. In our case, it is um, language X into English. And many to many is when you have many source languages translating to many target languages. So an example of our zero-shot model is, say we have Manipuri to English and we have some language X to English, but we want the translation between Manipuri to this language X for which no parallel data exists. Yeah, so this is what the zero-shot models will do. So in our case, the X represents Indian languages, which are Assamese, Bengali, and Hindi, and Manipuri. About the experiment part, so we are using an artificial token in our source sentences. It identifies what the source language is and what the target language is. And we have 4 rounds for our zero-shot machine translation, which are labeled as balance, round 1, round 2, and round 3. About the number of sentences that we are taking into consideration. So we are taking 5,000 sentences for training data and 1,000 sentences uh, for testing and validation. It's for single, multilingual, and zero-shot balance models. And for round 1 to round 3, we are increasing the number of sentence pairs of the training data by 2,000. About the languages used, we are using 5 languages here, which are Manipuri, Bengali, Assamese, Hindi, and English. And for the experiment setup, the tool settings is we are using OpenNMT and RNN model with encoder type BRNN and decoder type RNN. And since we are using very less amount of data, we are using a dropout rate of 0.3. This is the result of our experiment. The first table represents the uh, result of single model and multilingual model, and the second table represents the result from zero-shot models. So as you can see in the first table, the multilingual models perform better uh, than the single model for an Indian language translated into English, except for Manipuri to English. And moving on to our second table, we can see that as we progress over round 1, 2, and 3, the translation accuracy increases. And another thing that we can observe is that Manipuri to Bengali performs the best among all the 3 listed language pairs here. And another thing we can observe is that uh, in round 3 of Manipuri to English, it is almost 2 times of the balanced translation accuracy. And for Manipuri to Assamese, we can say that it is increasing by 2 points as you progress through each round. Yeah, And for Manipuri to Hindi, at round 3, it increases by 7 times, multiplied by 7 of the balance translation accuracy score. Other things that we observed are the sentence behavior of the translated sentences in balance. So in terms of average number of words per sentence for each language, it is observed that it is half of the length of its reference sentences. And for all the language pairs, the average number of words in a sentence for training before addition of more data is lesser than the length of the test sentences. For example, Assamese to English has average number of words in training sentence, which is 16 words initially, and that of the added sentences for each round is 18. And what we have in the test set is the length is 20. Our neural machine translation system did not perform well in balance as you saw in the table. We could say that it was not good at learning short sentences. This could explain why the length of the translated sentences is only half of that of reference sentences with repeated words. For example, there are only 584 unique words out of around 15,000 words, which makes up 4% of unique words in the translated sentences of Manipuri to Assamese in balance. But as we progress with the rounds, the translation accuracy increased and the behavior of the translated sentences changed as well. What happened is the average sentence length of becomes closer to the reference as the rounds increases and the accuracy increases as well. The sentence length of Manipuri to Bengali is equal to the length of the reference in round 3, which is 17 words. And this language pair has the highest blue score among all the other pairs. So Manipuri to Bengali, as we saw earlier in the table, outperforms the rest. We could say that we could also add in by saying that Bengali have lexical influence on Manipuri. Also, it is followed by Hindi, Manipuri to Hindi, and Manipuri to Assamese, which exhibits the least score. To explain this, I could say that the fact that they do not influence each other directly, which means Bengali influences Assamese and Manipuri, but Assamese does not directly influence Manipuri, which is why we could see this score when it comes to Manipuri and Assamese. The conclusion that we can make is that even though there is an increase, the score overall doesn't have, our translation accuracy score overall does not have, are without no statistical significance. Maybe it is, I believe that it is because neural machine translation has a steep learning curve with respect to the amount of data. And this could be the result why we are, facing with low translation accuracies in this experiment. Thank you for listening.